Hello guys, welcome to another video. This one is paper 3-2 of May-June 2019. So let's move on to question number 1. So here we have to find the coefficient of x cubed in the expansion of these two functions. So now you observe we have this expansion right here with a power which is a fraction. So whenever you see that, you have to go to your list of formulas. You will see we have to use this one, right, where the power is a fraction, is rational. Okay, the power is a fraction. So let me write this down. First, when the power is a fraction, you have to use this formula. Okay, so here we have, it should be 1 plus x power n is equal to 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 times n minus 2 divided by 3 factorial x power 3, and it keeps going on, right? But here in the question itself, we only need to find the coefficient of x cubed, so we can just stop right here and expand and see what happens. So now let's expand this. So we have 1 plus 3x power 1 over 3. So by observation, if you're going to use this expansion, the value of x here will be 3x. So for x here, it is 3x. And the value of n should be 1 over 3. So we just have to replace back in this to solve this. So now the very important point is you have to make sure that whenever you are going to expand this kind of expansion, where the power is fraction or negative, you have to make sure that it is 1 for this constant. So for example, let's say you had something like 2 plus 3x power 1/2. So you have to change that to 1. And how would you do that? You would divide by 2. So you take a 2 everywhere. Be 1 plus, it will be something like that. So basically, you can take this out. That will be this. And then your expansion will be 1 plus 3 over 2 x power half, for example. But you need to make sure that this constant, it is 1. Here it is 1 already, so we are good to proceed to the expansion. So here you have, as you can see, 1 plus 3x power 1/3 is equal to, first term is 1, and n is 1 over 3, x is 3x, plus n is 1 over 3, times n minus 1 is minus 2 over 3, x squared will be 3x squared divided by 2 factorial, and plus 1 over 3, minus 2 over 3, minus 5 over 3, that will be 3x power 3, and divided by 3 factorial. So we can stop right here because, as you can see, we only need a term until x power 3, so we don't need to go more than this. Now let's try to simplify these terms one by one. So here we'll cancel out. You will have 1 plus x. Now this will become minus 2 over 9 times 9x squared over 2. Then you will have here plus, so we have 1, that will be 10, minus 2 times minus 5 will be 10, divided by 3 times 2 times 3, that will be 27, times 27 x cubed divided by 3 factorial, that should be 6. So expand, or we can just simplify. So 9 will cancel out, and 27 will cancel out. So you will have 1 plus x minus 2 x squared over 2 plus 10 over 6 x cubed. So we can still simplify. So the last step will be this one minus x squared plus divided by 2, 5 over 3 x cubed. So this will be expansion of this. You will get this. But now the question is, we have to expand this one, right? So basically now we have 3 minus x 1 plus 3 x this, and you know that this is equal to this, so you can replace 3 minus x times 1 plus x minus x squared plus 5 over 3 power x, so x power 3, sorry. So here, instead of expanding everything, as you can see the question, we only care about the coefficient of x cubed, so let's find the term in x cubed, right? So 3 times what will give you x cubed? 3 times this one. So it will be 3 times 5 over 3 x cubed. That is the first one. And then here we have minus x times this one. So minus x times minus x squared to give you something in x cubed. Now we can simplify. This one cancel out. You will have 5x cubed minus x cubed. That will be 4x cubed. So the question is only asking for the coefficient, which is 4. So that will be your answer. Coefficient of x cubed is equal to 4. Okay, so that will be your answer for question number 1. And this formula here will be given to you on the list of formulas. And the most important part in this expansion is to make sure that the first constant, it is a 1. And you can do this by, if for example that was 2, you will have to take this out and make it become 1. Okay, that will be your question number 1. Now let's move on to question number 2. So showing all the working, solve the equation, give your answer correct to 2 decimal places. Okay. Now we have 9 power x equal to 3 power x plus 12. So if you observe, what is 9? 9 is equal to 3 power 2. So we can rewrite this down here as 3 power 2 power x equal to 3 power x plus 12. Now we can bring this in. You will have 3 power x. We can take out 2 equal to 3x plus 12. Now something we can do is we can let, because this seems to be hard to work with, let's change that to something much simpler. Let's u equal to 3 power x. So this will give you u squared is equal to u plus 12. Okay, now let's bring everything to one side. You will have u squared minus u minus 12 is equal to 0. Now next step is to factorize this equation. It is a simple quadratic equation. U squared is u times u, and 12, the factors is 3 times 4, right? So we can use that to get minus 1. So 4 is here, 3 is here. To get minus 1, we have to have minus 4 plus 3. So your answer is u plus 3 is equal to 0. U minus 4 is equal to 0. So u will be minus 3. U will be 4. Now, we are not trying to find u. We are trying to find the value of x. So we have to replace this back in u. So u is equal to 3 power x minus 3. 3 power x equal to minus 3. Sorry, it is 4, not 3. That is 4. Now, for this one, if you were trying to solve the value of x, so whenever you see x is on the power, you want to bring this down. To bring this down, you have to apply logarithm on both sides. We take ln on both sides. ln of 3x and ln of minus 3. That will be x, ln of 3, ln of minus 3. Now the only problem is that ln of minus 3, it is not possible. As you can check, ln of minus 3, it is not possible. So in that case, it is no solution, so it is invalid for this part. So we reject this one. Now we only have this one. So same steps to bring the x down, we have to take ln on both sides. ln 4. Now we can bring this down. You have x ln 3 is equal to ln 4. X will be ln 4 divided by ln 3, or ln 3, right? Now let's solve this. Ln 4 divided by ln 3. That should be 1.261859. Now going back to your question, give your answer correct to 2 decimal places. So finally, x is equal to 1.26. That will be your answer for question number 2. Okay, now let's move on to question number 3. So showing all the working, solve this equation for theta between 0 and 180. So step by step, so the first thing you realize is that you should know what is cot. Cot of 2 theta is equal to 1 over tan 2 theta. Okay, that is the first thing we can observe from that. Now we can replace back in your equation. Let's see what we have. So on one side we have 1 over tan of 2 theta is equal to 2 of tan theta. Right. Now, as you have seen in your list of formula, you have something for this expansion, right? So let's go back to the list of formula that you will have. So it's right here. So tan double angle is equal to something like this. So let's write this down. So basically we have tan of 2 theta should be equal to 2 tan of theta over 1 minus tan square of theta. Now we have to replace this back. So here we have 1 over this. So 1 over tan of 2 theta. We just have to reverse this upside down. You will have 1 minus tan square theta over 2 tan theta. So now replace this by this on this side, right? That is your main equation. Yes, so you will have 1 minus tan square theta over 2 tan theta equal to 2 tan theta. So the reason why we need to change that to this, because since the angle are different, we cannot work with them. We have to make them become the same angle, and then we can simplify further. Okay. Now this is a fraction here as well. We have to cross multiply. You will have 1 minus tan square theta equal to 4 tan square theta. Now let's rearrange, send everything to one side. You will have 4 tan square theta. Then we have plus tan, so that will be 4 tan square theta plus tan square theta is equal to, so I don't think we need to send the 1 because we have to solve this, right? So leave the 1 on the other side. Now you will have 4 plus this will be equal to 5 tan square theta equal to 1. So now we can solve this equation, right? So make tan the subject of formula. You will have 1 over 5. So tan theta is equal to plus minus root of 1 over 5. So we will have 2 possible solutions for that one. So let's look at one by one. So on one side we will have tan of theta is equal to minus this, and on one side we will have tan of theta is equal to plus 1 over 5. Now when tan is negative, we know that by drawing our quadrants, it should be in our second quadrant, which is 180 minus theta, and it should be in your fourth quadrant, which is 360 minus theta. So let's do that. So first we have to find the value of this theta. So this theta right here is basically tan inverse of the positive value of root 1 over 5. Okay, so let's do that. That will be in degrees, tan inverse of root 1 divided by 5. That should be 24.1 degrees, right? Now from this we can find the value of theta. Theta is equal to, going back to your quadrants, the first one is 180 minus this, so 180 minus 24.1, that will be 155.9, or it can be 360 minus 24.1, that will be 335.9. That is the two values when it is negative. Now going back to the positive one, so when tan is positive, it will be in your first quadrant and also in your third quadrant. So it will be 180 plus this angle. So same thing, to find this angle, we have to take tan inverse of the positive value of this one, which will be the same, 24.1. So from this you will have theta, going back to your quadrants, first one is this, so 24.1, and then that will be 180 plus that, 180 plus 24.1, 204.1. So now going back to your question, we only need values of theta between 0 and 180, so we have to cancel those values which is outside the range. So theta will be 24.1 or 155.9. That will be the two values of theta that satisfy your equation. And so let's move on to question number 4. So find the exact coordinates. So we have to find a point of x and y of the point of the curve y equals to this, at which the gradient of tangent is equal to 1 over 4. So now, by now you should know, whenever you see gradient of tangent, what does this mean? So let's write this down. Gradient of tangent, it always means dy by dx. Now we have to find the point when dy by dx is equal to 1 over 4. So now we have to find dy by dx. So we know y, and to find dy by dx, we have to differentiate. This one is a fraction. So when it is a fraction, we have to use your quotient rule, right? So dy by dx is equal to, the first term we have to write the denominator as it is, so 1 plus ln of x multiplied by the differentiation of the numerator. Then minus, so write the numerator as it is, then differentiate the denominator, and now everything will be divided by the square of the denominator. Okay, so now we just have to simplify one by one. So this one will be the same, so 1 plus ln of x times 1, now minus x times, now d by dx of 1 is 0, plus d by dx of ln of x will be 1 over x. And then all this thing will be divided by 1 plus ln of x squared. Now we just have to simplify, so that will be 1 plus ln of x minus, so x times this will become 1. So everything again divided by 1 plus ln of x squared. Now we have 1 minus 1, they will cancel out. So you will have ln of x on top and 1 plus ln of x squared on the denominator. And that is your dy by dx. So now we have to find the point where dy by dx is equal to 1 over 4. So let's equate that to 1 over 4. So next step, whenever you have a fraction equal to a fraction, you have to cross multiply. You will have 4 ln x is equal to 1 plus ln of x power 2. Now we have to expand this right now. You will have 1 plus 2 ln x plus ln x squared. This is equal to 4 ln x. Now send everything to one side. You will have ln x squared. So here we have plus 2, minus 2 should be, so minus 4 should be minus 2 ln of x plus 1 equal to 0. Now as you can see, we have ln x, so it is kind of hard to understand what's happening, so we can do this. Let u equal to ln x. So you will have u squared minus 2u plus 1 equal to 0. Now you can see this one is a simple quadratic equation. So we can first factorize and solve for the values. U times u, 1 is 1 times 1. Now to get minus 2, we have to have minus 1 to be at minus 2. So now when you solve this, as you can see, u is equal to 1. But of course, We don't care about u, we want to find x, so replace back. You will have ln of x is equal to 1. So x will be exponential 1, so exponential. So we have found x, we have to find the value of y as well, because we are trying to find the coordinates of a point. So y is this, so replace in your equation. Y will be x over 1 plus ln x. So y is equal to exponential 1 plus ln of exponential. That will be exponential over 1 plus 1. That should be exponential over 2. So the point finally is x is 2 and y will be exponential over 2. And that is your question number 4. Now let's move on to question number 5. So throughout this question, the use of calculator is not permitted, so you have to show every step of your work to get your full marks, right? It is given that the complex number minus I plus root 3i is a root of the equation. This is the equation that is given to you, where k is a real constant. Now, part 1, write down another root of the equation. So whenever you see write down, it means that you don't need to do any kind of calculation. It should be pretty easy. So something to know is that whenever you have a complex number as your root, and you have to know that the conjugate of that complex number is also your root. So you write minus 1 minus root of 3i is also a root. That is something to know. That is for 1 mark. Now going on to part 2, find the value of k. So first find the value of k and the third root of the equation. So let's do one by one. So first step is to let p of x equal to your polynomial, which is kx cubed 5x squared plus 10x plus 4 equal to 0. Now, we know that one of your root is equal to x is equal to, it is given to you by the question itself, minus 1 plus, so minus 1 plus root 3, I is one of your roots. So basically by a theorem, if you were to do this, replace this root by the value of x, it is supposed to give you 0. So basically, let's do that. We will have k root 3 I of power 3 plus 5 I of power 2 plus 10 and plus 4, that is supposed to give you 0. So now we have to simplify each term to see what happens, right? So let's first find this one. So we know x is this, so x squared will be minus 1 plus root 3i squared. That will be 1 minus 2 root 3i plus 3i squared, which is equal to, so we have to know I squared is equal to minus 1. So 1 plus minus 3, that should be minus 2 root 3i. So replace back in your equation. So first one here, we will have 5 times minus 2 root 3i. That is the first thing to write. Now this one we can just simplify. It's the same thing. That will be minus 10 plus 10 root 3 I plus 4, that is still 0. So here we have to find this one now. So what is power 3? As you can see, x power 3 is equal to x squared times x. Now we know these two terms, so x squared is minus 2 root 3 I times x, which is minus 1 plus root 3 I. Now expand one by one, so minus 2 times this will be 2 minus 2 root 3i, and this times this should be plus 2 root 3i minus 2 3i squared. That should be given to you by, so as you observe, these two will cancel out. So we will have 2 here. That should be minus 6i squared. Now I squared is minus 1, that should be 8. So if you replace back here, you will have k times 8 plus this. Now we have to expand. You will have 8k that will be minus 10 root 3i minus 10 plus 10 root 3i plus 4 is equal to 0. So these two will cancel out, and then you will have minus 10 is minus 20, plus 4 is minus 16. So 8k minus 16 is equal to 0. So 8k is equal to 16. K is equal to 16 divided by 8, which is 2. So first we have found the value of k, which is equal to 2. Now we have more space here, so let's do the rest over here. So for now we know what? We know that p of x is equal to 2x cubed plus 5x squared plus 10x plus 4. Okay, now we know the roots. X is equal to minus 1 plus root 3i, but also minus 1 minus root 3i, right? Because it is the conjugate, it will be another root. So by knowing all this now, the question is to find the third root. So because it is a cubic function, it will have 3 roots. We know 2 of them, we have to find the third one. So now you have to know how do you write your roots as your factors. For example, when I say, so this is only an example, when I say x is equal to 2, that is a root. So what is a factor? Factor will be x minus 2. So same way, this is the root. So what is the factors? It will be x minus, that will be your first factor. And then your factor for this one will be x minus, that will be x, that will be plus 1 minus root 3i, and this is x plus root 3i. Okay, so first, as you guys know, usually when you have real factors, you will just first find the equation by multiplying them together and do long division of this polynomial to find the quotient. So that will be your third factor for this equation. So let me show you guys what do I mean. I will first have to multiply these two. So we do x plus 1 minus root 3 times x plus 1 plus root 3 to get your quadratic factor for this equation. So if you expand, you will be first x times this, you'll have x squared plus x plus root 3 xi. Okay, now 1 times this will be plus x plus 1 plus root 3i, and this time this should be minus root 3 xi minus root 3 I, and then plus 3. So that will be actually minus 3i squared. Now simplify. So here we have this one will cancel out with this one, and this one will cancel out with this one. So if you observe, we have x squared plus x is 2x. Then we have plus 1, that will be minus, so 3i squared will be I squared, as you guys know, it is minus 1, that will be plus 3. So you will have x squared plus 2x plus 4 is your quadratic factor of that equation. So basically, since we know this, so basically we have p of x is equal to something, x squared, this, plus this, and we're trying to find the other factor, which we don't know. So we can find this by doing long division. Okay, so we take p of x, which is 2x cubed plus 5x squared plus 10x plus 4, then divide by this one. So now the first question that I can ask myself is, how can you make x squared become 2x cubed? Have to multiply by 2 first, and the next you will have 2x cubed. So this time this should be plus 4x squared That should be 8x. This one cancel out, minus minus, so 5 minus 4 is 1, and this will be plus 2x plus 4. Now next step is how can you make this become this, multiply by plus 1. So you will have the same thing, right? Square plus 2x plus 4, and that is 0. So basically, as you can see right now, my p of x can be written as x squared 2x plus 4, and we have 2x plus 1. That is the other factor. Now we want the other root. The root we have to equate to 0. For this one, that will be 2x plus 1 equal to 0. So 2x will be minus 1, x will be minus half. So the third root will be x equal to minus half. And that will be your question number 5. So now let's move on to question number 6. So in your question, you will see that this region here are the shaded region, okay? So I think my ink is done. That's why it's not shaded, but that is the way it will be in your main question. Okay, so let's move on to the information now. So in the diagram, A is the midpoint of the semicircle. So here we can see we have a semicircle, and A is the midpoint of the semicircle, which means this will be 90. Okay, and that's all we know for now. Now, also, it is with center O and radius R. So the radius of this semicircle is R, and OA is also R. Okay, that is something we need to know. Now, a circular arc with a center A, so we have center A, and the arc is BC. It means the circle at B and C, and the angle OAB is equal to x radians, as you can see right here. So now, if you observe from what we have been told from part A, since A is a midpoint of the semicircle, these two has to be the same, and this is x, and this also has to be x. Okay, so just so you know what's happening, right? Now we have to use this information for later on. The area of the shaded region is equal to half of the area of the semicircle. Now this is for afterwards, so let's proceed to part 1. It says using the triangle OAB to show that AB equal to this. So we have to find AB, but first we have to use the triangle OAB. Now first step is to connect O2 to B and see what can we derive from the triangle OAB. Okay, so the first thing we realize is that OB is also the radius. That will be R, and we have this is x, so these two are the same length, right? So this is R, this is also R, which means this is x, this also has to be x. So if I take this out, for example, let's say I take this triangle out, I will have AB, and the point O will be somewhere around here. That is O, that is B, and that is A. So this is the angle X. We know this is R, and this is AB. So we have to find AB. So how can you find AB? Since we know these two sides, and we know this angle, we can use our cosine rule, right? So you can say cosine of x of the angle, it is equal to square of both sides, which is R square, plus AB square, minus, of course, minus this side square, divide by 2 times R times AB. Now let's simplify step by step. So these two will cancel out, and we have to cross multiply, right? So you will have 2 RAB is equal to, so cos x is equal to AB square. Now here we have AB, here we have AB square, we can cancel out. So you will have, finally, AB is equal to 2R cos x. This is shown as required. Okay, that is for part 1. So here we have AB, which is equal to 2R cos x. So now if you observe, we take into account our area of the shaded region. So that will be what? A, B, C. It is a sector, right? And the angle here will be combined will be 2x. So this is AB will be the radius of that circle, and BC will be also the radius of that circle, which means AC is equal to AB, which is also 2r cos x. So now we have to use this information for your next part. It says part 2, hence show that this is true. So to find this, we have to use this information. The area of the shaded region is equal to area of half the area of the semicircle. So we have the equation here. Area of shaded region is equal to half of area of semicircle. Okay, so let's see how can we find each of them. So first let's proceed with this one. This one is the easiest. So what is area of semicircle? So to find that, we first need to find area of circle, which is pi r square. Semicircle will be divided by 2, and that will be half times this. That is for the right hand side. And what is area of shaded region? As you can see, we have a sector ACB, angle 2x, and radius 2r cos x. So we have to find the area by using your formula, which is area of sector is equal to half r square theta for the angle. R square is your radius. So that will be half times r square, which is 2r cos x square, times the angle will be 2x. Now if you observe, these two cancel out. So if you expand, you will have, on one side you will have 4 r square cos square x times 2x is equal to x pi r square over 2. Now next step, here we have x cancel out. Here we have r square cancel out. So you will have, we can also send 2 over here, right? So send 2 over here, you will have 4 times 2 is 8, times 2 will be 16. 16 cos square x is equal to pi. So pi, that should be, so let me see, pi, that is pi. Now I think something is missing here for my values. Okay, here it is missing something, because half r square x will be this one, 2x, x will be, so okay, there's no x here. That's the problem. So here it is multiply, it's not an x, so x remains, and there's no x here. The x here will be remaining. Okay, that is an issue that I have. Confused this as x, but that should be multiply. Okay, so just be careful for your questions here. So here we have x, and here it is not x. So basically we will have x times this equal to pi. Now simplify, we have 16 cos square x equal to pi divided by x. So moving on, that will be cos square x is equal to pi divided by 16x. So from this you can write down cos x will be square root of pi over 16x, and that will give you x will be cos inverse of root of pi over 16x. And this is shown as required for part 2. Okay. Now let's move on to part 3 of your question. Now verify that by calculation x lies between 1 and 1.5. Okay, so right now we have x from part 2 is cos inverse of root of pi divided by 16x. So we have to let this equal to p of x, for example. Right, now for the first thing is we take the value of, let x equal to 1. What is the value of p of x? So p of x equal to 1. So let's do that. So inside we have pi divided by 16, root of answer, and cos inverse, that should give you 1.11. So basically for the first value, 1 is less than 1.11. Okay, now we assume x is equal to 1.5, which is this value. So p of 1.5 should give you what? Let's see. So 16 times 1.5 should be 24. So pi divided by 24. Now we have square root of that, and cos inverse, that should give you 1.20. So as you can see, 1.5 is more than 1.20. As you can see here, we have a change of sign from less than to more than. So you conclude, since there is a change of sign for the values of x is 1 and x equal to 1.5, we conclude that the value of x is between 1 and 1.5. Okay, that is for part 3. Now for part 4, use an iterative formula based on the equation from part 2 to determine the value of x correct to 3 decimal place, but give the results of each iteration correct to 5 decimal place. So the formula for part 2, it was x equal to cos inverse bracket square root of pi over 16x. So to write the formula, we have to re-express this in terms of an iterative formula. That will be x n plus 1 equal to cos inverse bracket root of pi over 16xn. Now we have to solve for the value of x. So first one is, let the value of the first x equal to the midpoint of those two. So 1 plus 1.5 divided by 2, that will be 1.25, which is exactly in between those two values. This is the first value. So 1.25 will be your first value as your answer. Now for the next value we have to use, let's do this. So first, cos inverse of root of pi divided by 16 times answer. Okay, so that should give you the following values. Okay, so x2 will be equal to 1.163. So we have 28 correct to 5 decimal place. Then we have 1.14742. Then this is x3. x4 should be 1.14432. Next one should be 1.14370. Then we have x6 1.1435, so 358. x7 1.14355, and x8 1.14355. Okay, so we can stop right here. As you can see, your value of x correct to 3 decimal place should be 1.144, 3 decimal place. Okay, and that will be your question number 6. Now let's move on to question number 7. So the variables x and y satisfy the equation, as you can see here, the dy by dx equal to x times e power x plus y. Now it is given that the value of y is 0 when x is 0, so we have to keep this until the end to find your you have your value of c for your constant of integration. So here, first thing first, solve this equation. So we have to obtain x in terms of x, or y in terms of x, sorry. So at first we have dy by dx is equal to x times this. So now we can simplify this. We have to use our laws of indices. So when you have this plus this, it is also equal to times e power x. Now replace this one back to your equation. You will have x e power x times exponential y. Now let's break this down. Let's send all the y to one side, and this dx, send this to one side. So you will have dy is equal to something dx. So x will be x exponential x, and y will be 1 over exponential y, because when you send this over here, it will have to be divided to here, right? Now once you have this, you have to integrate the two sides. So let's do one by one, not to confuse the steps. So first one is the integration of 1 over this. So we can rewrite this as, we can bring this up, it will become exponential this dy. So that will equal to this divided by minus 1. That is basically minus this, or you can write this as 1 over exponential y, up to you. You can write this here or here, up to you. Now for this one, integration of x exponential x dx. So as you can see here, we have two different kind of function. This one is algebraic function, this one is exponential. So when you have two different kinds, usually you will have to use integration by parts. So when using that, you have to choose which one is going to be your u and which one going to be your dv. So as you know, the formula is uv minus, that will be v times du and dx, right? So let's do that. So let's choose which one is going to be our u and v and dv, sorry. So we have to follow the rules of Late. So this is your logarithm, this is your algebra, this is trigonometry, this is your exponential. So here we have algebraic function, and here we have exponential. So whichever happens first, we will define that as u. So here you can see a happens first, we will say this is u, and this is dv for the second one. Okay, so right now we have u is equal to x for the algebra, and dv is equal to the exponential, which is e power x. So we have to find du. So du by dx will be 1, and v will be integration of this, will be the same thing. So now next step is to replace these values back in your equation. So u is x, v is this one, minus root of v is this one, and du is 1 by dx. Now simplify, that will become x exponential x minus exponential x plus c. So back to your main equation, on one side you will have, let's write this down as minus exponential minus y is equal to x exponential x minus exponential x plus c. So now we have to use these two values to find the value of c. We know that when x equal to 0, the value of y is equal to 0. So put it back here. Minus exponential power 0 is equal to 0 times exponential 0 minus exponential 0 plus c. So now anything power 0 is 1, that will become minus 1, and this will be 0 minus 1 plus c. From this you can clearly see that c is equal to 0, right? If you send this over here, become minus 1 plus 1, that is 0. So finally your equation looks like this: exponential minus y x times exponential power x minus this. This will be your equation. But now the main question is to express y in terms of x. So we have to make y become your subject of formula. So how can we do that? We could have factorized the e power x outside, right? So let's do that, because that will make things simple for us. So let's cross this out. You will have, your equation should be exponential minus y is equal to exponential x minus x exponential x. If you observe here, we can factorize the exponential outside. Have exponential 1 minus x. Okay, this will help us to make this become more simple. Now take ln on both sides. You have 1 minus x. So we can bring this one down. That will become this, ln of e. And this, we can break this down into two parts. So by the laws of logarithm, because you have multiply, you can break this down into addition. That will become plus 1 minus x. So this one will be equal to 1. so you will be cancelled. You will have minus y equal to x. This also is the same thing, 1 plus ln of 1 minus x. So finally y is given by minus x minus ln 1 minus x. That is as simply as possible y in terms of x. Now let's move on to part 2 of the question. Explain why x can only take values that are less than 1. So from this question, you have to basically look at this one. We know that we have a restriction here because logarithm cannot take negative values. So you can write down, since cannot take negative values, so we need 1 minus x to be more than 0. Now simplify, that will become this more than minus 1, x has to be less than 1. So this is shown as required for that question. So it is less than 1. So that will be your question number 7. Okay, so let's move on to question number 8. We have f of x equal to this expression. So first one is we have to express f of x in partial fractions. So step by step, we have let f of x equal to, here we have a linear fraction, that will be a over 2x plus 1, then plus b over, that will become 2x plus 3, and we have, this will become c over 2x plus 3 square. Now we have to solve to find the value of a, b, and c. So f of x is also equal to 10x plus 9 over 2x plus 1 times 2x plus 3 is equal to a over 2x plus 1 plus b over 2x plus 3 and plus c over 2x plus 3 square. So as you can see, we have fractions over here, fraction over here. We can send this over here to simplify. So a over this times this, you will have a times 2x plus 3 square, and plus b times this, b over this times this, you will have 2x plus 1 times 2x plus 3, and finally c will be just 2x plus 1. So on top we will have the same thing, which is this. So now we have to solve to find the values of a, b, and c. Now we will do this by the method of elimination. For example, if I want to eliminate c and b, I will take the value of x equal to minus half. So how do I know this? So the way I find this is, I take this value right here, I equate that to 0. So x will be minus half. So that's how I find the value of x equal to minus half. So if you do that, that will become minus 5 plus 9 is equal to a. So 2 times x will be minus 1 plus 3. That should be 2. That will be 4. Plus this will become 0. So b times 0 will be 0 plus 0. So you will have 4 equal to 4a. So a is equal to 1. That is your first value. Now we can replace that back in your equation. We have 10x plus 9 equal to 2x plus 3 square plus b 2x plus 1 times 2x plus 3 plus c 2x plus 1. Now let's say I want to eliminate everything else except c. I will have to equate this one to 0. So 2x plus 3 equal to 0. X will be minus 3 over 2. So we take the value of x equal to minus 3 over 2. So that will be 10 times minus 3 over 2 plus 9 is equal to what? This will be 0 square plus b times 2 plus 1, but that will be 0. So this will be remaining, which is plus c times 2 times minus 3 over 2 plus 1. Now let's simplify. This will become minus 15 plus 9 is equal to 0 plus 0. This is minus 3 plus 1, that will be minus 2c. So minus 15 plus 9 is minus 6, so minus 6, let's check. Yep, minus 6 is equal to minus 2c. C will be equal to 3. So finally, you will have on one side is 10x plus 9 is equal to a is 1, so 2x plus 3 square plus b we don't know, that is 2x plus 1 and 2x plus 3. C is 3. Okay, so now we have this. So now we can try any value that you want. So what is the simplest value to try? We can try x equal to 0. So this is just any value you can choose. It doesn't matter, okay? So if x equal to 0, this will be 9. And this will be 9 as well. So 2 times 0 is 0 plus 3 squared will be 9 plus b. So that is 1 and that will be 3 plus 3 times 1. So you have 9 plus 3b plus 3. So if you observe, we have 9 cancel out. 3b will equal to minus 3. So b is equal to minus 1. Okay. So from here we have the values of a, b, and c. A is equal to 1, b is equal to minus 1, and c is equal to 3. So basically, your f of x in terms of partial fraction is equal to a is 1 over 2x plus 1 plus minus 1, which is b, over 2x plus 3, and finally c will be 3 over 2x plus 3 square. So now for part b of this question, we have to show that integration of f of x equal to this value. Okay, this is the exact value. We have to show that. So first, let's rewrite down f of x in terms of your partial fraction. So as you have seen in part 1, it is equal to 1 over 2x plus 1 minus 1 over 2x plus 3, and then plus 3 over 2x plus 3 square, and this is of course with respect to x, dx. So let's do one by one. So first you have to know how do you integrate something which is like this. So this is equal to, so this is an example to help you do this too. It will be equal to ln of the inside value, which is 2x, of the denominator, then divide by the differentiation of 2x, which is 2. So you will have half of ln of 2x. That was an example, so now we have to do these two. So for the first one, we have differentiation of 1 over 2x plus 1 dx. That will be equal to ln of the denominator, which is 2x plus 1, then divide by the differentiation of this value. So d by dx of this value, that will become 2. So you get half ln of 2x plus 1. Now same thing for this one. It is this and 1 over 2x plus 3 dx. So you have ln of the denominator divided by the d by dx of this value, that will be 2. So you will have half of ln 2x plus 3. Now finally for this value, you observe that we can rewrite this down in terms of, you can bring the power up, that will become 2x plus 3 power minus 2 dx. And this is equal to, 3 is only a multiple, you can just leave this outside. And you have to first increase the power by 1, so minus 2 plus 1 will be minus 1, then divide by the power, then divide by the differentiation of the inside, that will be 2. That will be minus 3 over 2, and you bring this down and become 2x plus 3. So next step is to replace all these answers, these three answers, back in your main integration. That will equal to half ln of 2x plus 1 minus half of ln of 2x plus 3 minus 3 over 2 of 2x plus 3. And of course the limits between 1 and 0. So let's just replace the values one by one and see what happens. So first one is x is equal to 1. You have half of ln. So 2 times 1 is 2, plus 1 is 3. Minus ln of, that will be 5. Minus 3 over 2 times, this is 5. That is when the value of x is 1. Now minus when the value of x is 0. You will have half of ln 1 minus half of ln, that will be 0, that will be 3, and minus 3 over 2 times this will be 6. So simplify. So here you will have half of ln 3 minus half of ln 5 minus 3 over 10 minus, this will be 0. If you check, ln of 1 is 0. That will be 0. So here you will have minus half of ln 3 minus 1 over 2. Now let's simplify again. So here we have half of this plus half of this. That should give you 1 of ln 3. If you check, because here we have half of ln 3, minus minus is plus, so plus half become 1 of ln 3. Okay, that was the first one. And here we have minus half of ln 5, and here we have minus 3 over 10. Minus minus become plus, so 3 over 10 plus half, that should be 4 over 5. So minus 3 over 10 plus half, that should be 3 over 5. From what I can see, it says, let's check. So here we have ln 3 minus half of ln 5. That will become, so minus 3 over 10 plus, say 1 over 5 plus 1 over 5. So now we have to try our best to make this become like this. So if you observe, we can rewrite 3 as what? 3 is equal to square root of 9, which is 9 power half. Now if you replace, ln of 3 will be ln of 9 power half. So here we have half ln of 5 plus 1 over 5. Now for the power, you can send this to the beginning. That will become half ln of 9 minus half ln of 5 plus 1 over 5. Now we can factorize the half outside. You will have ln of 9 minus ln of 5 plus 1 over 5. And finally, for your answer, half is half, and when you have ln and minus, you can combine them. 5 will become divided, 9 divided by 5, plus 1 over 5. And this is shown as required for this exact value. And that will be your question number 8. So now let's move on to question number 9. So we have the points A and B have position vectors this and this. Now, the line L has equation this given to you. So R, this is for line L. So let's write this down in terms in vectors. It is easier to understand. So 2, 1, 1 plus mu 1, 1, 2. Right. This is for your line L. Now we have the points OA is given to you by 1, 2 minus 1, and OB is given to you by 3, 1, 1. That is the two things that we know. Now it says show that L does not intersect the line passing through AB. So we have to still find the line passing through AB. So how do you find the equation of a line? As you can see, for example, equation of a line is equal to a point on the line, so point on line, which is a vector, plus direction of line. Okay, that is only an indication. So to find the equation of the line that goes through AB, we have to find the direction of AB. So let's do this. Let's call this line, let's call it the line P or Q, I don't know, Q, line Q. So to find the direction of the line, we have to find direction of AB, which is equal to OB minus OA. Okay, so OB has been given to you as 3, 1, 1 minus OA, which is 1, 2, minus 1. That is 2, that is minus 1, and that will be 2. That is the direction of your line, which will go here. Now, a point on the line can be anything. You can choose any one of those. So basically, your equation of your line Q, which we say it is this line for now, it is basically R is equal to, point on the line, we can choose any of those two. Now, okay, we can choose this one, plus, let's use lambda, because here we have used mu already, times the direction of the line. Okay, so from this, we have to show that these two lines does not intersect, so we have to try to solve them simultaneously and check if they do not intersect. So if you were to expand those two, you will have 1 plus 2 lambda, 2 minus lambda, and minus 1 plus 2 lambda. This is your x, y, and z, right? So same thing for here as well. If you were to, let's continue here, that will equal to 2 plus mu, 1 plus mu, and 1 plus 2 mu. That'll be your x, y, and z. So we just have to try to solve them, see if they meet with each other or not. So we have to equate them, which is R, L equating to R, Q, and see if they match the values or not. So let's do that. So on one side we will have this one, 2 plus mu, 1 plus mu, and 1 plus 2 mu is equal to 1 plus 2 lambda, 2 plus 2 minus lambda, minus 1 plus 2 lambda. Now for the first line, it is your x. Let's compare that first. So let's say for your x, we have 2 plus mu is equal to 1 plus 2 lambda. So mu is equal to 1 minus 2 is minus 1, so 2 lambda minus 1. That is your first equation. Now let's take for the value of y. Y you will have 1 plus mu is equal to 2 minus this one. So this is equal to 2 minus 1 is 1 minus lambda. Equation number 2. So we can solve this too to find the values of mu and lambda. So let's do this here. So you will have, replacing each other, you have 2 lambda minus 1 is equal to 1 minus lambda. You will have 3 lambda equal to 2. Lambda is equal to 2 over 3. Now for the value of mu, that will be 1 minus lambda, which is 1 minus 2 over 3, which is 1 over 3. So from this 2, you have seen that the value of lambda is 2 over 3 and mu is 1 over 3. So now we have to use those two values to check if this last one is true or not for your z coordinates. So on one side we have 1 plus 2 mu, which is 1 over 3, and one side we have minus 1 plus 2 lambda, which is 2 over 3. That is, so 1 plus this will become 1 plus 2 over 3, and this is minus 1 plus 4 over 3. So simplify, that will be 3, that will be 5 over 3, and this will become, so 1 over 3. So these two are clearly not equal. So because of that, since the z coordinate does not meet, we conclude that the line L and line passing through A and B do not meet. Does not meet or intersect. Okay, that is your conclusion by showing that these, for these two values, the last one is not the same. That will be part 1 of the question. Now let's move on to part 2. We have the plane M is perpendicular to AB. So from part 1 you have seen that AB has the direction of, so that was 2 minus 1, and 2. That is your direction of AB. And passes through the midpoint of AB. So what is the midpoint of AB? So let's find those information as we go. As you know, we have to do x1 plus x2. So we have been given AB already. So that is 1 plus 3 over 2. And for y coordinate should be 2 plus 1 over 2. And last one is minus 1 plus 1 over 2. That should be 2, 1.5, and 0. Okay, that will be the midpoint of AB by using those 2 points. Okay, so the plane M intersects the line L at P. So we know that this plane meets the line L at P. So L is equal to, it is given to us from part 1 as well, which is 2, 1, 1 plus mu times 1, 1, 2. That is your line L. So find the equation of M, first thing, equation of M, and then find the position vector of P where the plane meets the line L. So to understand how can we find the equation, we first have to draw something for your plane and for the line to see what's happening. So the plane is, looks like this, right? That is your plane, and plane is always described by their normals, which is that. So given that it is perpendicular to AB, AB will be perpendicular. So basically in this direction, it will be, if that was the surface of the plane, it has to be 90 degrees. So this is also 90 degrees to the surface. It means that N, which is your normal, is parallel to the line AB. So basically you have the direction for N that will be same as AB, which is 2 minus 1, 2. That's the first thing you have to find out. Now, as you know, how does equation of a plane look like? It looks like AX plus BY plus CZ equal to D. Now this value A, B, and C are these three values for your normal. That will be 2x minus y plus 2z is equal to D. So we have to find this value of D. So how can you find this value of D? If you have a look on the question itself, it tells you that the plane passes through a midpoint of AB, so it passes through this point. So we have to use this point to find the value of D. This is x, y, and z. Replace back in this equation, you will see what you will have. So 2 times x will be 2 minus y plus 2 times 0 should be your value of D. So D is equal to 4 minus 1.5, which is 2.5. So finally, your equation of plane M is equal to 2x minus y plus 2z is equal to 2.5. That is your plane M for part 1. So now you have to find the position vector of P. So the P is a point where the plane M and the line L, they meet. So line L is equal to this. We can rewrite this down as 2 plus mu, 1 plus mu, 1 plus 2 mu. This is your x, y, and z. Now replace those three in this equation. Let's see what we have. So you have 2 times x plus, so minus y plus 2 times z is equal to 2.5. Now we have to solve to find the value of mu and then replace back in to find the position of P. So first thing expand, you will have 4 plus 2 mu minus 1 minus mu plus 2 plus 4 mu is equal to 2.5. Now let's simplify this, right? So we have 2 mu minus mu is mu plus 4 mu is 5 mu. Then you have 2.5 on one side. We have to send everything to the other side. We have to minus 4 plus 1 and minus 2. That'll be minus 2.5. So mu is equal to minus half. If you check, minus half. Now for this value of mu, let's go back to your R to find the position vector of P. So finally, position vector of P, it is at this value of mu. So basically that will be 2, 1, 1 plus minus half times 1, 1, 2. That will be 2 minus half will be 1.5, right? And 1 minus half should be 0.5, and 1 minus 1 should be 0. So your position vector of this is equal to this, but now if you want to write back to in terms of I, j, and k, you can write down OP is equal to 1.5 I plus 0.5 j. And that is your question number 9. So always when you're about to do plain question, make sure you have a drawing to understand what's happening. But the main point here is, the main thing you need to understand is, if you have a plane is perpendicular to a line, so it means your normal to the plane is parallel to the direction of the line, which means when you have a line which is equal to something here, a point x, y, z, plus something times the direction, let's say 1, 2, 1, so it will have normal will be equal to this direction vector. So that's why you need to derive from this question, plane perpendicular to line means normal is parallel to this direction. Anyways, that was question number 9. Okay, so let's move on to question number 10. So the diagram shows the curve y equal to this equation for this domain from 0 to 1 over 2 pi, and its minimum point of m given to you right here. Now the shaded region is bounded by the curve and the x-axis, as you can see on the diagram, right? Now question is, by expanding this and this, show that we have this equal to this. So one by one, if you observe, this is basically sine 3x plus x is 4x is equal to basically, let's write down sine of 3x plus x. Now to expand this, you don't have to worry because we have been given the formulas to use to expand this. Okay, so let's write this down. On your formula sheet you will have, let me use a different color. It is given to you that if you take sine of angle A, if it was plus or minus, that is equal to, let's write this down here, it is equal to sine of A, then we have cos of B, plus minus cos of A, sine of B. So this is given to you on your formula sheet, so you can use that to find this expansion, right? Now as you can see, this is plus, you have to use plus sign. Plus will be on top. Now it'll be sine of 3x cos of x plus cos of 3x and sine of x. That is the first one. Now for this one, so 3x minus x is sine of 2x, and that is equal to, as you can see, that should be sine of 3x minus x. That will be minus, so you have to use the minus. Equal to sine of 3x cos x minus cos of 3x and sine x. Now we can just try to add those two, because here we have plus. Well, let's add those two. You will have, on one side you will have sine 4x plus sine 2x, and this side you will have this plus this side, so these two will cancel out, so you will have 2 sine 3x cos x. So now you can see we have to make this one become your subject of formula. So finally you'll have sine of 3x cos x is equal to half times sine of 4x plus sine of 2x, and this is your shown as required. Okay, now for part 2, using your result from part 1, so using this result, we have to find the exact area of the region R. So to find the area, as you can see, usually we have to use integration, but we also have to find where is this point x. This is the point where the curve cuts your x-axis. So as you guys know already, at x-axis your value of y is equal to 0. Okay, so as you have seen, we had been able to rewrite this as this is your new y, so equal to 0. So 0 equal to half sine 4x plus sine 2x equal to this one. Now this will be, if you cross multiply, this will be cancelled out, so you will have sine 4x plus sine 2x equal to 0. So now you observe that these two angles are not the same, so you have to change that to make it become the same. This one is 4x. We can definitely write this in terms of 2 times 2x plus sine of 2x equal to 0. Now go back to your formula sheet. You will find the formula for sine of 2x. So sine of 2x is equal to something like this, right? So let's write this down here. On your formula sheet, you will see you have sine of 2x is equal to 2 sine of x and cos of x. So you have to use this in here. But here the only difference is here we have x and 2 is outside, but here we have 2x. So if you observe, that will be 2. If you put 2x inside, what will happen? Your answers here will change as well, become sine of 2x and cos of 2x. Okay, so let's replace. You will have on one side you have 2 sine of 2x and cos of 2x plus sine of 2x equal to 0. So let's continue on the next page. So right now I have 2 sine of 2x cos of 2x plus sine of 2x. So the first thing I can do is to factorize the sine 2x outside. You will have sine 2x will be 2 cos 2x plus 1 equal to 0. So now let's find the corresponding values. So we have sine of 2x is equal to 0 and 2 cos 2x plus 1 is equal to 0. So as you can see on your diagram, the value of x will be between 0 and half pi. Now if you know x is between 0 and half pi, now which is exactly half pi is what? It is basically 180 divided by 2, that should be 90 degrees. Okay, that is your quadrant. But now we as you can see, we have 2x. So 2x will be between times 2 everywhere, you will have 180, which is pi. Okay, that is something good to know. Now let's solve to see what values we have. So here we have 2x is equal to sine inverse of 0. So 2x is equal to 0, which is also equal to we have will be 180 and 360 based on your quadrant, right? If you look at when sine is positive, it will be in your first quadrant and your second quadrant. If it is 0, we can also do 180 minus 0 will be 180, and if it is 0, it can also be 360. X will be 0, 90, or 180. But now as you can see here, x is before this is 90 degrees, has to be between those two. It is right here. So we don't have any values that is in that region, so these three will not be good values. Now for this one, we have cos of 2x is equal to minus half. Now when cos is negative, if you observe your quadrants, it will be in your second quadrant and your third quadrant. Now second quadrant is equal to 180 minus theta, and this is equal to 180 plus theta, right? So let's first find the value of theta. Theta is not the same as x, it is cos inverse of the positive value of this one. So let's find that cos inverse of, so let's first use degrees so you can understand that it is half. That will be 60 degrees. But we have to find the value of 2x, so 2x is equal to, look at your quadrants, the first one is 180 minus this, that should be 120, or it can be 180 plus this, that should be 240. So x will be 60 degrees, or will be 120. Now, let's express that in terms of, so if you observe, basically x has to be between 90 and 0. So 120 will be outside the range, so that will not be eligible. So now the last thing is we have to convert degrees back to radians. That will be equal to pi by 3. So that is your value of x that we have to use to find the area. Okay, so now I have run out of space. Let me use another page to find the exact area of that region. I think I have some space on the back. Let me do this on the back. Okay, so continue here for area. As you can see, it is simply the integration between the limits of 0 and pi by 3 of your equation. So integration between pi by 3 and 0 of y is now given by half of sine 4x plus sine 2x with respect to dx. Now we have to solve this. So we can just take out half. It is only a multiple. We don't care about that. So integration of sine will be cos of 4x and then divide by the differentiation of the angle. That should be 4. Plus, same thing, cos of 2x divided by 2. Limits of pi by 3 and 0. Now for you to, if you want to use degrees, pi by 3 is equal to 60 degrees. Okay, so let's solve one by one. We have half. So we can use cos of 4 times 60 degrees divided by 4. That will be minus 0.125 plus cos of 2 times 60 divided by 2. That is minus 0.25. So let's double check. So this one is 4 times 60. Cos of answer, that should be negative, correct. So that is your first part. Now we have to minus when it is 0. So cos of 0 is 1. That will be 1 over 4 plus 1 over 2. So let's simplify. This will become minus 0.125 plus, sorry, minus 0.25. That should be minus 0.375. Then here we have to minus 1 over 4 plus 1 over 2. That should be 0.75. Okay, so let's see what do we get here. So it feels like I made a mistake somewhere because my value is above the line. It should be positive. So what happened? Let me see what happened. Oh, I see now, because integration of sine is not cos. It should be minus cos. That's the reason why it is not right. So just to recap, the main reason why is because sine x by dx integration should give you minus cos x. Okay, so as you can see, it is really easy to make mistakes in math, so be careful when you do your integration. So that will become plus here, because minus plus, that will become plus here. Now that will become minus here, and here we'll have minus and minus. That will become plus. That is plus as well. Okay, so you will have half, and that is 0.375 plus 0.75. Now times half, that will be your answer, which is 9 over 16 units square. Okay, that is your answer for your area in exact values. Okay, so that will be part 2. So now for part 3 of this question. So using your result from part 1, express dy by dx in terms of cos 2x and hence find the x coordinate of m. So what is m? If you go back to your graph, you can see m is your minimum point, right? So let's do one step by step. So first we know that y is now equal to, from part 1, it is half of sine 4x plus sine 2x. So we have to find dy by dx. So let's do that. That will become, so half of, that will become, half is only a multiple. You can just take this outside. And this one will become cos of 4x times 4 plus cos of 2x times 2. Now we have to simplify. Bring this half in, so half times 4 will be 2 cos 4x plus 1 cos 2x. Now, so if you observe, we have dy by dx equal to, so here the angle are different. So here we have 4x and 2x. So the question says we have to express in terms of cos 2x. This is okay, but this is not okay. So we can rewrite this down as 2 cos of 2 times 2x plus cos of 2x. Now, how can you simplify this? So for this, you just have to use your formula sheet. You will see you have something right here. So cos of 2x is equal to this thing. So let's use that formula. So let me write this down here. We have to use cos of 2x is equal to 2 cos square x minus 1. So similarly, if you were to write cos of 2, then we change the angle to 2x is equal to 2 cos square 2x minus 1. Now replace back in your equation, you will have 2 of 2 cos square 2x minus 1 plus cos of 2x. Now let's expand and simplify. You will have 4 cos square of 2x minus 2 plus cos of 2x. Now this is your dy by dx in terms of cos 2x, which is plus cos 2x minus 2. Now we have to find, the next part is find the x coordinate of your point M. M is your minimum point, so you would say at M, you know that dy by dx has to equal to 0. So let's equate that to 0. So you will have 4 cos square 2x plus cos 2x minus 2 is equal to 0. So now let's check if this is factorizable. This is your b, this is your a, and this is your c. So b square is 1 square minus 4 times a times c. It is given by 33. So root of 33 is not exact, so we have to use our formula. So to find cos 2x, it is equal to minus b plus minus root of b square minus 4ac, that will be 33, divided by 2a, that should be 8. So let's find the values one by one. So for this value, we find the negative 1. So minus 1 minus root of 33 divided by 8 minus 0.843. Or it can be the positive value of cos 2x is minus 1 plus root of 33 divided by 8, 0.593. Now, you guys must know, let's find all the values and see which one is the right one, okay? So, when cos is negative, it will be in your second quadrant, and your third quadrant. Second quadrant will be 180 minus theta, and this is 180 plus theta. So first let's find the value of theta. Theta is not the same as x, it will be cos inverse of the positive value of this one. Let's see what you get. So cos inverse of 0.843. That will be 32.5 degrees. So now you have to find the value of 2x, right? So 2x, you have to look at your quadrant. The first value will be 180 minus theta. So 180 minus 32.5, that will be 147.5. And it can be 180 plus theta, that will be 212.5. So x will be equal to, in turn, divided by 2, that will be 73.8, or it can be 2.1 divided by 2, that will be 106.3. Same thing for this one. We have to solve. If cos is positive, it will be in your first quadrant and in your fourth quadrant, which is 360 minus theta. So first, to find the value of theta, it is cos inverse of the positive value of this. So cos inverse of 0.593. That will be 53.6. So now from this we have to find the value of 2x is equal to theta, which is 53.6, and then 360 minus theta. That will be 306.4. So x is equal to divide by 2, that is 153.2, and for this one that will be 26.8 for two values of x. So now we have to choose which one is the right value. So to know this, you have to go back to your graph. If you observe, m is right here between pi by 3 and pi by 2, which is between 60 and 90 degrees. So let's check which one is between those two. So by observation, this is okay, between 60 and 90, and this is not, and not. So your only value for x will be 73.8 degrees, but you have to convert this to radians. So now how do you convert degrees to radian? As you guys must know by now, we have 180 degrees is equal to pi radians. So 73.8 degrees is equal to pi divided by 180 times 73.8. So pi divided by 180 times 73.8. You will have 1.2. So correct to 2 decimal place, 1.29. So that is your value of x of the m coordinate. And that will be your last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.